Ah, Hi, everybody. This is Mr. Folly, and welcome to podcast 2.1. I might have hinted it might be 1.3, but either way, that's it. We talk a little bit about isotopic notation, average atomic mass, parts of the periodic table, and properties of protons, neutrons, and electrons. So let's hop to it. What does this mean? Okay, so you've seen these before sometime or another. I don't know when. But chemistry and middle school and all this other stuff. This Okay, so that is the mass, and the mass is found by adding protons plus neutrons. Okay, so I abbreviate protons P. Whoops, I abbreviate protons P positive. I abbreviate neutrons N with a zero, and I abbreviate electrons E negative. Okay, so this number right here is super annoying because it has so many names. This is the number of protons. This is the atomic number. And this is often forgotten, but used enough to annoy us, Z, which is kind of the nuclear charge. Okay? But they're all exactly the same thing. Okay? And then this, if it ever asks, is the symbol. So this would be sulfur. Now, I want to point out this mass is the mass of only this isotope. Okay? So that would be like my mom has a Rottweiler. It weighs 76 pounds. Okay. Now, the average mass of a Rottweiler is 80 to 110 pounds. Okay. I have a small Rottweiler. Okay. This one Rottweiler is 76, but this is your periodic table number. So if it was the periodic table, we might say the average mass of a Rottweiler is 101. So if you look at on the periodic table, it would say 101. If you look at the mass, so sulfur has a number right below it that is 32.06. Notice I intentionally picked a number that is not down. This number right here on your periodic table is the average, not for just that one. All right, I gotta remember. Oh man, I heard. Proton determines identity. Neutrons determine mass and nuclear stability. And electrons determine chemical reactivity. Oh, reactivity and charge. Okay. So your protons, your identity doesn't really change. You know, you are who you are. You're not going to suddenly wake up and go, oh, I'm somebody else. Look at me. That's it. Okay. So you need to know that protons will determine your identity. If you know the number of protons, you know its identity, which would be, it'll never say this, but this might be helpful for you. This tells you the symbol on the periodic table. Okay. Okay, you don't need to write down all this. This is just to give some context. You don't need to write down any of this. I'll tell you what you need to write down. Where does the mass in the periodic table come from? Scientists chose carbon 12 to have a mass of 12.000000000 forever. Okay, carbon's the most abundant element in living things. They saw it as the most important. They saw it as the baseline. So and its mass was 12-ish, so they called carbon 12 12. This gave us the mass of a neutron and a proton. So a proton and a neutron have very, very, very similar masses. So I'm making this up. If a neutron weighs 1.0000000, a proton would be 1.00013. So it's it's the same for a bunch of significant figures. Okay. So what we do is we average every atom of each isotope to get the average atomic mass. So for example, when I talked about that Rottweiler thing, I said my mom has a small Rottweiler. If I took 1,000 Rottweilers and took the average mass of them, then that would give me that 101 pounds for it. Okay. Now they might not have used 1,000, or they might have done 10 samples of 1,000, or they might have done 10 samples of 1,000,000,000 or whatever. Okay. To make life easy, we say a proton and a neutron weigh 1 AMU. It's an atomic mass unit. So they just made up that number that was based on something. Like a fathom. Fathom's a made up number. Fathom's a pretty cool unit if you look it up for its story. There are 3 isotopes of hydrogen. Oh, what did you need to write down? No single element has the mass of the average from the periodic table. Okay, PT is periodic table. This is what you need to have written down. That's the important part. Okay. No single element has the mass of the average of the periodic table. Okay. There are 3 isotopes of hydrogen. We got yourselves a 1, we got yourselves a 2, we got yourselves a 3. What is the average mass of H? You'd probably guess it would be 2, but you'd be wrong. Because what happens is 99.999999999% is hydrogen 1, and 0.001% is deuterium, and 0.031% is tritium. Okay, so because of that, what's the average mass of hydrogen? If you look, or if you recall, it's 1.008. Okay, so we don't have to actually calculate it right now, but just realize that knowing just the identities of the isotopes is not enough. None. 0. Okay. How many carbon atoms weigh 12.01? That's the average mass. None of them will weigh the average. How likely is it if I grab one boron atom, it will 10.8? So boron weighs 10.8, 0. Okay. This number came from the periodic table. Okay, so how do we find this average atomic mass? So naturally occurring europium consists of 2 isotopes with a mass of 151 and 153. Europium has an abundance, europium-151 has an abundance of 48.03, and europium-153 has an abundance of 51.97. What is the atomic mass of europium? Okay, so what you do here, it's called a weighted average. All you do is percentage 1, mass 1, plus percentage 2, mass 2, and then there could be more of them, equals average. Now, I went to a hillbilly school in Indiana, and they told me you never do math with the percentage sign. So you have to move that decimal 2 places over. I kind of like that. I kind of like being a little bit hillbilly. So you're going to do 0.4803, and mass 1 is 151. Europium 151 has an abundance of 48.03. Ba-ba-boom. Abundance 2 is point. Notice how I moved the decimal. Make it the decimal form of the percentage, and that was 153. Calculators assemble. I just did this example. You should write this example in your notes. If you don't write it down, it didn't happen. I know you probably followed this pretty well, but if you forget how to do it, you want to have a sample problem right there in your notes to make your life wonderful. And I got 1 theta 2.04. I'm going to go for it. I'm going to go 2 decimal places. Just go around. Okay? So, and does that make sense? It should be pretty close to the middle because these are about 50-50, right? But it should be a touch closer to 153, and it is a touch closer to 153. I'm so sad about formatting, so equals mc squared. You lose some mass to binding energy. This means the mass of protons plus neutrons do not equal isotopic mass. So that's just, we'll get into that a little bit more later, but some of the mass of an atom is turned into energy to hold it together using that equation. No calculations at this point, just so you know. So we lose some mass, what is called binding energy. Binding is tying up, right? So if I have this guy here and this guy here, or so if I have a neutron and a proton, and a proton. So if I'm talking about, say, helium, I've got to have these two protons packed in close together, right? Well, protons repel each other, but so it takes energy to group, bond might be the better word, two protons. Where does that energy come from? That energy comes from the mass of protons and neutrons. That's it. Calculate the average atomic mass of magnesium using the following data for 3 magnesium isotopes. So notice they give you relative abundance in the decimal form. Makes it a bit easier. So remember, I do percent 1 mass 1 plus percent 2 mass 2 ... okay, equals the... So percentage 1, 0.787 times 23. Wow, I just misspelled 23. Times 23.985. Notice how it's not an even number. Magnesium 24 weighs 23.985. That's going to happen, right? So if it tells you that's what it is, that's what it is. Okay? Oh, why would you do that to me? I'm just trying to erase you. There we go. Ooh, let me try and change to a different color. Ooh, how exciting. Plus percentage 2. Oh, come on. Percentage 2, 0.1013 times 24.986. I know you think I'm going to do another color still, but I'm not. I'm full of trickery today. 1117 is my percentage, and my mass is 25.983. And then I gotta go. So 0.787 times 23.985. Now, I should notice that my biggest abundance is 24. So my answer should be closest to 24, but bigger than 24. Plus quantity 0.1013 times 24.986, closed quantity, plus quantity 0.1117 times 25.983, closed quantity, and I get 24.3. And then that mass is U. I usually use AMU instead of U. Both of them are okay. But just be aware. I like to show you the different ones in case AP gives you a different looking unit. Okay, calculate the average mass of this substance and predict the identity. So I did all of this typed out for you. Okay, so here's what I did. So this is the mass spec data of an element that I got from the lab we did yesterday. All right, so I just put one in there. The greatest intensity, the 100% intensity, was 24. Okay, then I had to estimate what do I think 25 and 26 are. Okay, so I estimated that 25 was 10%. Looking right here. Oh, where's my pen? You punk! What is this doing to me? Okay. So I estimated that 25 was about 10%, and 26 was about 12%. It's a little bit bigger, and I just estimated. Okay. So now I have to turn those into percentages. So remember, you can't have something be 122%. So what that means is if this is 100, and this is 10, and this is 12, if I add them all together, if I add them all together, I get to this math wrong. It's so embarrassing. Oh, I call it 15, not 12. That's fine. And I call this 15. Then I add them all together. 100 plus 10 plus 15 is 125. Okay. So my percentage for this one would be 100 over 125. This would be 10 over 120. And this would be 15 over 125 because my total is 125. Okay. And then that gave me my percentages. I left them in the decimal form because that's the way I like it. And then my masses are 24, 25, 26. And I did the same math I did before. And what I got was 24.3. And guess what? That's magnesium, just like we did. Calculate the average mass and identify it. Okay, so this says M over Z. M over Z is just mass. If you ever see it, it confuses you. Relative intensity, I wish it didn't say percentage because that's just, it is percentage. You know, this is 100% intensity, and this one is, I don't know. So what I'm going to do is I'm going to try and cut it in half a bunch of times. Half, that's 25. Half, ooh. So I'm going to call that 10%. Okay. So I'm going to say 10%, 6, and so then we're going to deal with a total of 110. Okay. So my percentage of 7 is going to be 100 over 100. I just misspelled 110 over 110. So 100 divided by 110, I can't believe I put that in a calculator, 0.909. And then I'm going to have 10 over 110. And that's going to be my percentage of 6, which is going to be 0.0909. And then I'm going to do my problem like before. Percentage 1, M1, plus percentage 2, M2. Ooh, my computer's getting glitchy. So I'm going to say if I do that, what I get is 6.9, which equals lithium. I'm just worried my computer's getting all kinds of moody. So again, my mass is 7 and 6, and that's where I would use the right ones. Don't be glitching. Parts of the periodic table, we didn't do that yet. No protons, neutrons, and electrons contribute. Know the difference between isotopes compared to other atoms. So if I have the isotope, 2 isotopes of sulfur would be sulfur 34 and sulfur 32. But a different atom might be something totally different, like phosphorus. Oops, I just misspelled P. Phosphorus 32. Okay, so these are different atoms. And then these guys right here are different isotopes. So since my computer's looking kind of glitchy, I'm going to let it go. We are all done. Yay! I will say this to you with great joy. Doodles.